Okay, 10% of wholesale price. See, here's the example. Also, you need to do your homework based on this example. Okay, so see the ordering cost for one of the retailers is 100, 1,100, and so on. That's the annual demand. See, 100, 1,100, and so on. Okay, the demand is 1 million, 2 million, 3 million. Okay, it's all based on the numeric example in the paper. So there's a lot of numeric example. There's the fundamental one. There's the very first one. Okay. So they define the AS is 500 as M equal to 10 because there are 10 retailers. And actual saving is 10%. Actual saving is 10%. So AS again is 500. Sorry, it's a duplicate one. So before CRE, T stop. Okay, there's a TI stop before CRE, and there's a total cost of each retailer before CRE. Then there's the order processing cost. That's also before the CRE, right? That's before the CRE. In the paper, there's a comparison of the total cost before and after CRE. So we need to calculate the total cost for the vendors before CRE. Okay? So the result here is the 294, 223. And inventory holding and ordering cost for the whole system is this. Then we need to get it done this way. So previously this is only ordering and processing cost. So this one is plus the total cost of the retailers. This is the total cost for the supplier. Okay? That's the total cost of the whole system. So here is for the whole system. Also, sorry, this is WHOLE, this is not WHOLD. For the whole system. Okay. Okay. I copy everything. So it originally was wrong. Everything was wrong. So then, this is the so-called NI stop. NI stop. Based on the formula, there's a ceiling of it. We define the NI stop. So also we define the ZI. EI is equivalent to the formula in the PowerPoint. Okay. And then the paper told us, okay, after some calculation, okay, the optimal T0 from the vendor's point of view is 2 weeks. Okay, 2 weeks. It's 2 weeks. Here I only calculate for one T0. Okay. But for you, you need to calculate for all the possible T0 given in the homework. Okay, to see which one would be the best one. Okay, including this example. Okay. So how to calculate? Yeah. So T0 is 2 weeks. So 2 weeks divided by 52. Okay. Okay. Because of the paper, there's some tricks in the paper. For example, in the one problem during the midterm, I told you that there's only 250 days, working days per year. Right? For some papers, it may define based on the working days, 250. But for this paper, since I checked it out, it's based on the what? Calendar day. Okay? But it's still simplified by what? 52 weeks. Actually, 365 days is not equivalent to 52 weeks. But all the calculation in the paper is based on the 52 weeks. Okay? So then, since we need to find out the maxima z, so we need to calculate all possible zi. Okay? And then ZZ means the maximum one. Okay, representing the price discount. So this is the output for all the Z. So which one is the biggest one? This one. Okay. So pick up by this one. So ZZ is the maximum over the ZI. Okay. So this is the price discount. So the vendor order processing cost after CRE is based on the formula. Okay. Then we can get the numbers here. Is 177, 338. I should pronounce it like 177 and 328. So the vendor saving is what? You see? There's a vendor saving. There's originally vendor's cost. This is the original one, difference between the original one and GT0. GT0 is here. No? There must be somewhere. Oh, yeah. This is GT0. Yeah. So the vendor's savings before and after the CRE is what? 39.73%. Okay. So retailer's cost before and after the CRE. Okay. And the retailer's saving is 70.41%. Okay. And system saving is 26.30%. So all this number consistent with here. You see? All here. The number are consistent. Okay. Okay. Any question so far? And then one more. About your homework. Optima T0 from the vendor's point of view is 2 weeks. For the first we make example in the paper. Okay, show the result for T0 is not only for 2 weeks, including 1 day, 2 days, 3 days, 1 week, and 10 days, 2 weeks. Okay, and 4 weeks to determine whether T0 equal to 2 weeks is still optimal for the first example. Okay, so you just rerun the same procedure. Okay, but you need to determine the total cost for all possible choice. 1, 2, 3, 4, 5, 6, 7. There are 7 choices. Okay, that's the first question. The second question is if the demands for 10 buyers are reduced by 90%. So 1 million become how much? 100,000. Right? Reduced by 90%. Okay? What is the optimal T0? For T0 equal to 1 day, 2 days, 3 days, 1 week, 10 days, and 2 weeks. Because of what? The demand become less only with the what? 90%, right? Only with 10%. So T0 is dropping down. Okay? If you found 1 day is optimal, you may try half a day. Okay? To see. Okay? Since this is not okay, the total cost function. Actually, this is the total cost function here. It's not convex. Okay, it's not convex. And the computation is so-called NP hard. So you may need to also plot the T0, and here is the total cost. Of the supplier. For example, here is 1 day and 2 days and so on. So it's the different total cost. Yeah, it may increase it as this much. Okay. So that's why we need to calculate all the values for T0 to find the minimum one. Unlike the EOQ analysis, we can take the first and second derivative, okay, and then locate the global minimum of that. So this is the NP-hard problem. The paper also mentioned about this is very complicated. Last time I told you for the final exam, okay, maybe like more than 60 or 70% of the problem is based on the mathematical. All you need to do is just rerun the program, okay? But you need to tell me what's going on inside. That's another 70%. Okay? So which implies as long as you can finish your homework, I mean step by step, you may have 70% of the total score. Okay. So don't worry too much. I'm not going to ask you the model development, since it's kind of too complicated at this moment. I just try to let you feel about how the inventory supply chain system works. Okay? Actually, one of my students, she is working on the problem based on CRE, but the demand is influenced by the wholesale price. I mean the retail price. Okay, retail price. So do I have the similar question here? Oh, this one, like this one. So that's the, we have two more papers for JEI's problem. Okay, the very last I haven't finished yet. So this is so-called the inverse demand function of the retailer. So this is the demand, this is the price. Okay, if the price increase, demand is going down based on the formula. Okay, based on the formula. So her thesis is working on this one, and also try to solve the supplier's inventory problem. Because of the Miss Watterson paper is so-called lot. There's no inventory cost, except the ordering cost. Okay, there's no inventory holding cost for the suppliers. So her thesis is working on how to determine the supplier's inventory holding and ordering cost, and also with the so-called price-sensitive demand. And this kind of demand is well known in retail industry, and also is well known in marketing. Okay. Okay. So I just finished introducing this one, this CRE model. And then after the break, I'm going to introduce so-called a supply chain model for vendor management inventory. So it's a VMI model. So by Dong and Wu in Transportation Research Part B, appeared in 2002. And then this is also has a so-called leader and the follower. Okay, and also for this one is efficient replenishment in the distribution channels. This paper is appeared in Journal of Retailing. Okay, so certainly the so-called price-demand relationship need to be discussed. Otherwise, it's become the pure cost. You see, so efficient replenishment in the distribution channels. The paper is appeared in 2007. Actually, we can see the very first one appears in 1976, and then the JERS become very popular after 1986. So, how about this one? It's all CRE. See, like what? 15 years after this one. Okay. So since what? Last time I told you about the supply chain terminology, right? Though this paper, they all discuss the supply chain inventory problems, but there's no terminology about the supply chain. But how about this one? See, 2001. Almost the same problem, in a sense. The name is become the supply chain. Okay? After the supply chain, actually, around the 1980s and 1990s, there's a so-called vendor management inventory, so-called VMI appeared in the market. Okay? But never talking about the supply chain model. So this may be the very first fields talking about VMI under the so-called supply chain structures. How about this one? Distribution channel. Very relatively new in the industry because of the around 2003 or 2, everybody talking about the channel instead of the supply chain. Why we need to talk about the channel? Because of the what? The retail price appeal. See, this one there's no retail price. Even the paper simplified the wholesaler price as a unit 1. Okay. So I'll introduce this one. This is also this one. Two parties need to determine the wholesaler price. Need to determine the wholesaler price, and this one is also need to determine the wholesaler price. So that's so-called the channel. So-called the channel. Okay, let's take a break.